All right, so happy Wednesday. We're going to look at arc length and sector area today. So just a quick refresher on circumference and area of the circle. So circumference is equal to 2 times pi times the radius. So in this picture, my radius of the circle is 8 inches. So my circumference is going to be equal to 2 times pi times 8 inches. Anytime you're looking for a length or an area, you always want to include the units. I'm going to multiply the 2 times the 8, make this 16 pi inches. This is my circumference. This is a perfectly acceptable answer. Or I can multiply by pi. On your calculators, you have a pi button. So I can do 16 pi. I can hit this button, where is that? Right above the enter. That will give me the decimal approximation. So if you're going to round, we need to round to 2 decimal places. We need to round accurately. So I have 50.27 inches. So either answer is acceptable. So when you're doing your homework, you can either leave the pi symbol and have that be in your answer, or you can multiply it out. For the area, my area is equal to pi times the radius squared. So be careful. Both of these equations have pi and r and a 2. The circumference is times 2, and the radius is, and for the area, the value is squared. So same picture. So my area is going to be equal to pi times 8 inches squared. Area will always have a squared unit. So this ends up being 64 pi inches squared. And then to find my decimal approximation, I'm going to do 64 pi. I'm going to go ahead and put my little left and right arrow thing, and it'll round it for me. So 201.06 inches squared. So again, either answer is acceptable. All right, so we're going to look at the length of an arc. So we've talked about arc measures a lot. Let me get a extra piece of paper. So if I have arc AB, I can talk about two different things with arc AB. I can talk about the measure of arc AB, which is going to be measured in degrees, and I can talk about the length of arc AB, which is going to be measured in whatever unit that I've measured my radius in. So if this is 5 inches, the length of arc AB is going to be some set in inches relating to this. So it is like taking a piece of string. I threw away my ribbon from the other day, but it's finding out how long is this piece of ribbon that's going to go from A to B on my arc, if I were to lay it flat, for my length of AB. But the measure is going to be in degrees. So if this is a 62-degree central angle, this is a 62-degree arc measure. So the measure is in degrees, and it's part of the entire, I want to focus. Oh, there we go. It's part of the entire angles inside of the circle, which is 360 degrees. But the length is going to be part of the circumference. Okay, so I'm looking to see what portion. I have a circle here. This radius is 8 inches. Same radius as above, but I have this section that is highlighted. So my highlighter didn't quite work so well when I printed it off in black and white. So I like to call this a piece of pie. The piece of pie is called a sector. So a sector is a piece of pie, and it needs to be formed from a central angle. All right, so I'm not going to look at one of those pizzas where you eat a piece like this or you take the squares. No, it's got to be from a central angle. All right, so if I look at this sector and I look at this arc length, I can make 4 equivalent central angles from this and have 4 equal sectors. So if I'm looking at what portion of the circumference is highlighted versus the whole circle, this is 1/4 of the circumference. And then if I look at the area of the whole circle, there are 4 equal sectors. So this is also 1/4 of the area. So if I wanted to find the length of the shaded region, I would need to find the whole circumference and then divide it by 4 to get 1/4. If I want to find the area of this piece of pizza, I would need to find the area of the whole circle and then divide by 4 to find 1/4. But what if I didn't have a nice 1/4 90-degree angle? I can take the central angle, which is 90 degrees, and divide it by 360, which is all the degrees that will be in a circle. If I reduce 90 over 360, I get 1/4. So I can find the length of any arc and the area of any sector as long as I know the central angle and I divide it by 360. That will give me the portion of the circle that I'm looking for. So I've got 2 formulas for you today. One is for an arc length. So here's something to write down. This, if we had a milestone, it would be given to you on the milestone. So it's not something that you need to necessarily memorize, but we're going to use it a lot. But if we're looking for the length of an arc, my formula is dealing with the circumference. 2 times pi times the radius. That's the circumference of the whole circle. But I don't want the whole circle. I just want this portion of the circle. And this portion of the circle is theta. Remember, this is my x for an angle. And they're using the x for the angle as the central angle, divided by 360. So this is the actual measurement of this arc divided by 360, which is the measurement of all the arcs added together in a circle. The same holds true for my area of a sector. So the area of a sector is the area, but not the whole circle. It's just a portion of it. So I'm going to use the area formula, pi times r squared. But I'm not going to look at the area of the entire circle. I'm going to look at a portion of it. What portion? It's going to be my theta. Again, that central angle over 360. So both of these formulas will be given to you. You can use them, and they don't need to be memorized. But area uses the area formula. The arc length uses the circumference formula. And then both of them have that same theta over 360. So I've got an example here to work through. This is super messy. This is 13 feet for my radius, hard to see. And then my central angle is 135 degrees. I'm going to find the length of the arc and then the area of the shaded region for this sector here. So for the arc length, I'm going to use that formula. So I have theta, which is 135, divided by 360. And then that's times the whole circumference. So 2 times pi times 13 feet. I can type this whole thing into my calculator, not the feet, and it will give me my value. So I'm going to use a fraction, 135 over 360, and then times 2 times pi times 13. And I get 39 pi divided by 4 feet. And if I want to turn that into a decimal, I have 30.63 feet. I'm fine with the fraction and the pi, or we can round it to 2 decimal places. For the area of the sector, my formula, we have 135 over 360, my theta over 360, and then I use the area formula. That's pi times 13 feet squared. I can type it in just like this without the feet. I'm going to put my 13 in parentheses because I only want to square the 13. So I get 507 pi divided by 8 feet squared, and then my decimal approximation is 199. So I need to round around to 0.10 feet squared. All right. I'll have another video where I'll work out 3 additional problems. So if you'd like to see more problems, I'll see you there. But I have some homework posted. It is due on Thursday as an upload. Please let me know if you have questions.